Hello guys, this is another video. So we'll be looking on another technique of integration called approximate integrals. So in approximate integrals, approximate integration, we look on four concepts. So number one, we talk of Riemann sum. We'll talk of trapezoidal rule. We'll talk of midpoint rule. We'll talk of Simpson's rule. So this is where we are given a function of a curve, told to find the area or approximate the area of the curve using these four techniques. So I'll start with the trapezoidal rule. I'll start with the trapezoidal rule. Show how to handle questions on that. So this is approximate integration. So in trapezoidal rule, okay, trapezoidal rule, we can approximate areas of curves, areas of integrals using trapezoidal rule. So we have a formula on that. We can derive the formula, but the video will just be talking on an example, the formula, how to handle the formula, and so on. So the formula is derived from the word trapezium. So area of a trapezium is a half into a plus b of h. So the area is derived, the formula is derived from here. But for this tutor, for this video, we won't do the derivation, we just go straight to the formula. So we'll say area of any integral or any curve using trapezoidal rule is approximated to be delta of x divided by 2 into y naught, okay, plus 2 into y1 plus y2 plus continue till y into n minus 1, okay? Then we add y to the n. So this is the formula of finding the areas of curves using trapezoidal rule. So this is how it is. So right away, I will start with the formula. I will start how to explain each part of the formula using an example. For note, okay, delta x is the width of the trapeza. So and delta x is calculated as b minus a divided by n, the number of triangles that you require. For this case, n is usually given. Okay, so having these, let me find an example. So I'd say find the area given by the integral of x squared from 0 to 8 dx. This is an example. So this example allows us to handle how to maneuver with that formula. So by that integral with n equals to 4. N equals to 4. So we are actually given 4. We are actually given the value of n. So straight away, let's compute our delta x. So our delta x will be now, our delta x is the bound of the integral. So it's from 0 to 8. So it will be, so this is usually our b, this is usually our a. We can graph that integral. If you graph it, we will get our graph as this is the Cartesian plane. Okay, so this is the y-axis, this is the x-axis, this is the x-axis, this is the y-axis. Graphing this plane, we get this is a U-curve that opens up, so it will open up that way. Okay, it usually opens up that way. So we are told to find the area of this curve. So this curve is y equals to x squared. Okay, that's the curve. So it's from 0 to 8. Let me say this is our 8. Okay, so we are told to find the area of this region. Okay, we are told to find the area of this region. So the first step is, let's calculate our delta x. Our delta x will be the interval 8 minus 0. So it will be 8 minus 0, that is b minus a, divided by the value of n, that is 4. So it will be 8 over 4. Our answer is 2. So our delta x is 2. Okay? So we have found our delta x. So let's compute our y0. Then our y1, our y2, and so on and so on. So from here, okay, let me clear here. Allow me to clear. This is the trapezoidal rule. Keep in mind that is the trapezoidal rule. So this is our delta x. So the formula says area equals to delta x divided by. So let's compute our y1. What's our y1? So we'll have to draw a number line. We have to draw a number line. So we have to draw a number line. So this is not even a number line, this is just the x-axis from here. So this is the x-axis from 0 up to 8. So our x-axis, so it's from 0. Then we say the delta x is the interval of the trapeziums inside this region. Okay, so we say the first trapezium, the first interval is 2. So from 0 we'll go to 2. Okay, so this is our first delta x. So that trapezium is something of this sort. So we'll have something like that. Okay, so this is our first trapezium, something like that. Okay, our second trapezium, using that interval, it will be from 2 to 4. Okay, again, second one will be from 2 to 4, 6 to 6, then 6 to 8. Okay, so from there we'll have to compute our y0. This represents our y0. So we shall say this function is y equals to x squared. So what will be our y at this point? Our y at this point is where x is equals to 0. Okay, so I will clear this. I'll clear that. So this is where y equals to x squared. Our first y, our y0, our y0, okay, is where the value of x is 0. So it will be 0 squared, that is 0. Okay. Then our y1 will be where x is 2. So it will be 2 squared, it will be 4. Our y2 will be here. Our y2 will be where x is 4 squared, it will be 16. Okay. The third y, or y3, will be where x equals to 6, so it will be 6 squared, that is 36. Okay. We already found our delta x to be 2, our delta x 2, keep that in mind. So our y4 will be equal to where 8, x is 8, so squared equals to 64. Okay. So having that, let's substitute in the formula. So we'll say our area, allow me to, knowing this graph, the way it looks, let me just clear it. So substituting into our formula, we'll get our area, okay? Our area to be approximated as delta x. What is the value of delta x? We said it was 2 divided by 2 into, okay? Our y0, what's our y0? It's 0. Then plus 2 into, what's our y1? 4. Plus, what's our y2? 16. Plus, what's our y3? 36. Close the bracket. Then we add the last term of y, so it will be just plus 64. Okay? So the expected answer. Expected answer will be 1 into, so add this, 4 plus 16, 20, 20 plus 36, that is 56, 56 multiplied by 2, 112, so it will be 112 plus 64, plus 64, okay? So your answer is expected to be 176. Okay, adding this and this multiplied by 176 square units. So that's our answer. Okay, so this is our final answer. Dealing with that. So in approximate integration, we find the areas of curves using trapezoidal rule. So in this trapezoidal rule, we look another concept on it. So it's called the error bounds. So we'll calculate how to find the error bounds using trapezoidal rule. So this is our answer. But before we do this, let me just do the exact area, the exact value of the area. So the exact area, okay, of the integral. This is the integral, remember? The integral was x squared from 0 to 8 dx. So the exact area, when integrating these, add the power 1, so it will be 1 divided by 3x to the 3. Okay? So we'll just say 1 over 3 multiplied by 8. Just place the bounds from 0 to 8. Multiplied by 8 cubed. Okay? Minus 1 over 3 multiplied by 0 cubed. So the expected answer is 170. The exact area will be 170 and 2 over 3 square units. So this is the exact area. Okay? So we look, having these concepts, we have approximated the area to be this, then we have found the exact area to be this. So there is an error. There is an error that has occurred. So we can, at first we can calculate the percentage error given or occurred. So the percentage error, we calculate the percentage error as, okay, so this is the approximate area, this is the exact area, exact, okay, then area being approximated is 176 square units. So from here, let's calculate the percentage error that has occurred now. So the percentage error, okay, is the same as 176 minus 170. Okay? So it will be 176 minus 170 to the 3 over 3 thirds. We'll get 5 and 1 over 3. So it will be 5 and 1 over 3 divided by the exact area, that is 170 and 2 over 3 multiplied by 100%. So that allows us to find. So these are concepts in high school. We usually teach, calculated the percentage error. So how will we get our percentage error? It will be 5. It will be our 5. Okay. 5 and 170 over 3 multiplied by that. What will be our answer? So we'll get 3.125%. That's our percentage error. But for this case, it's unnecessary, but I was just showing how to calculate that. So from there, that's the percentage error, right? We're talking from here. Let's talk from here. Let's discuss. So we want the exact area. Okay. So our discussion. So we're saying the exact area is 172 over 3 square units. The approximate area is 176 square units. So there's an error that. So from here, there's an error that has occurred. So we have to calculate an error, an upper bound error. So that's what you say error bounds. So we have a concept we talk of error bounds. Error bounds. So in error bound, the concept is what's the error, the maximum error, the upper bound error that someone can commit. Okay? That someone mustn't exceed for the approximate area to be within the range of accuracy. So error bounds are calculated as, so error bounds are just the upper bound area where someone is allowed, that's the maximum error someone is allowed to commit while approximating areas using these approximations. So error bound, for trapezoidal rule, we say the error using trapezoidal rule, okay, is calculated as k into b minus a to the third divided by 12n squared. Okay, we have our n, it was 4 from our mind. We have our b, we have our a. Remember the integral was the integral from 0 to 8 of x squared dx. I draw a new graph for that. Opens up. So we have our b, that's our b, that's our a, okay. So we have to calculate our k. How do we calculate our k? Okay, sorry, here it's less or equal to, okay? Our k, the value of k. So the value of k, okay, is greater or equal to the absolute value of the second derivative of f of x, so just y. Okay? So this is how we calculate our k. So let's compute our k. First, to get the error bound for that. Trapezoidal rule. So our k is just y equals to x. So we usually say y equals to x squared. Okay? So our y, the first derivative of y will be 2x, right? Our second derivative will be just 2. So the value of y will be 2. The value of k will be 2. Why? It's just a constant. Okay? It's just a constant, so it will just be. So our value of k will just be 2. I will show another example where you find the second derivative to be maybe 2x. Okay, for example, let's calculate where we find our second derivative, our y prime, I say it's maybe 2x, something like that. Okay, so for this case, it's just a constant, so just the value of k will just be a constant. So for this other case, this is just another example to extrapolate more. I will find my value of k as where I will substitute my first part of the curve. I will substitute x with 0, so it will be 2 times 0, that answer will be 0. Okay, that's my first value of k. The second value of k will be 2 multiplied by b, that is 8, so I'll get 16. So in cases where you want to get a constant term, okay, maybe you get a constant term multiplied by a variable, just replace the variable with the bounds, so 8 and 0. So we have the two values of k. So we usually take the largest of the largest value of k. We have 2 k's, okay, so there's 0 and 16. So if I told you our second derivative of 2x, we would have used our k as 16, not 0. Okay, so for this case, this is just an explanation. For this case, our k is 2. Okay, for that case, our k is 2. Our k is 2. Okay, keep that in mind. So I will say, so our k is 2. From there, so from there I will say the error involved in trapezoidal rule, okay, is less or equal to our value of k 2 into what's our b? Our b is 8 minus 0 to the cube divided by 12 multiplied by the value of n, remember, was 4 squared. Okay, so my answer will get as 5 and 1 over 3. So that will be my error bound. Okay, so my error bound, I'll write error involved in approximating any trapezoidal rule, okay, will be equal to 5 and 1 over 3. So just an explanation for that. Okay, an explanation for this. We usually say this is the maximum error that one is allowed to commit. So the error must be either less or equal to this. It mustn't exceed this. This is the upper bound error. So the error usually must be less, okay, or equal to, so it will either equal to 5 and 1 over 3 for this curve, or less than 5 over 3. That's the error that you are allowed to have. So like your area must be ranging where this error can allow the ranges to. So maybe when you're calculating the areas, then you find your error, the error after subtracting the exact error with the approximate error, then you find it's greater than this. Automatically you will be wrong. Okay, you will be wrong. So this is the upper bound error. You are not allowed to exceed this. Okay, so that's the last concept on that trapezoidal rule. Okay, my second video will do a video on midpoint rule. Okay, don't forget to like, share, and subscribe. It's the prof. Thank you.